We are taking chapter number 4, which is motion in a plane. A ball is dropped from height 90 meter on a floor. At each collision with the floor, the ball loses 1/10 of its speed. That means 9/10 of the speed is remaining, or it remains. We have to plot the speed time graph of its motion between t equal to 0 to 12 seconds. So this is what is happening. That is, we have taken from 0 to 12. This is in hours, so we took 0 to 12, and these are the speed. We'll know how this speed is going to come. We'll use some formula, etc. But this is the graph of the object or ball falling. This is speed time graph. So what is happening? The ball is dropped from height. So height is given as 90 meter. We'll take like this. Initial velocity, because it is coming from the rest or starting from the rest, the initial velocity is 0. There is an acceleration because the ball is dropping. Acceleration due to gravity is also in the same direction. So we'll take A as positive 9.8 meter per second square. But the final velocity is not known to us, which is v. Let us use the second equation of motion in order to find out the time. We'll put all these value in s equal to ut plus half a t square, and when we find out the time, it will be 4.29 seconds. We'll use again this equation, first equation of motion, v equal to u plus at, in order to find out the velocity. What is the velocity? So time we have found out, just put it here. U and a we know. So the velocity comes to be 42.04. Now it is being said that once it collides, then it retains 9/10th speed. That is, it loses 1/10. So 9/10 of this 42.04 will be what? 37.84, right? So this is the value which has come. Now time taken by the ball in order to reach maximum height is obtained by the equation v equal to ur plus at. Now the initial velocity we'll use as the velocity we have just found, that is 9/10 of 42 something. Acceleration is always 9.8, but in this case first it hits and then again goes back. So now the direction has changed. The acceleration is like this, gravity. So we'll use minus this, and again it is going to be at rest so that it comes back. So the final velocity will be 0. Initial velocity is 9/10 of the velocity we found, and the gravity will be minus 9.8. So what will be the time t dash? It will be 3.86. If you find this out, it will be 3.86. So what will be this t plus t dash? It will be 8.15 seconds. The time of ascent is equal to the time of descent. So the ball takes 3.86. So it goes up and then it goes down. So 3.86 is again the time for the next striking of the floor. The velocity with which the ball rebounds from the floor, again we have this speed now. This will be the initial speed for the second rebound. 37.84, 9/10 will take, this will be 34.05 meter per second. And again the speed, or you can say the time was this, and 3.86 was the time. We have to add this so that the time taken by the ball for the second rebound can be found out, that is 12.01 seconds. And this is the speed time graph of all the values which we found out. This is starting, we have just given a kink because the speed is starting from this, so 34 to 42 will take, and from here we'll go up to 20 because we just have to find out till 12. So this is how it is going. The speed was 42, then it came like this speed 37.84, then it came like this, because at this point when it reaches height it becomes 0. Then again it goes back till 12, this t equal to 12, and the speed would be 34.05. Explain clearly with example the distinction between magnitude of displacement, also called the distance, over an interval of time, and the total path length covered by particle over the same interval. So the magnitude of displacement over this is the shortest distance, that is the straight line, or you can say perpendicular distance between the initial and final position, whereas the total path length is the actual path covered by the particle in that particular time. So if you go like this, come here, go like this, this plus this plus this is the path length, but this and this means this distance is your perpendicular distance, which is, this distance is displacement. Suppose we have, let us take one more example. We have a particle which moves from A to B, then comes back to point C. So A here, B here, and C is here at some time t. The magnitude of the displacement of the particle will be what? This AB, then BC, AB plus BC. And we should know that the magnitude of displacement can never be greater than the total path length. It can be total path length can be equal or greater than the displacement. So both the quantities may be equal at some time. The next part is magnitude of average velocity over a time interval and the average speed over the same interval. So what is the average velocity and average speed? And then we have to talk about the greaterness of the quantities as well. So what is the magnitude of average velocity? It has to be displacement by time interval. For any particle, say average velocity here. When we talk about the displacement, it has gone from A to B, then came back at C. So initial and final position is A and C. So we'll say AC by T. But when we talk about average speed, we have to take total path length. So we have to take first AB and then we have to add BC also. The total path length by time interval is AB plus BC by T, and this AB plus BC has to be greater than AC, or it is greater than AC. So average speed is greater than the magnitude of average velocity, and these two quantity will be equal if the particle continues to move along a straight line. Now the next question is, a man walks on a straight road from his home to market 2.5 km away with a speed of 5 km an hour. So here he goes up to 2.5 km and the speed is 5. Finding the market close, he instantly, without waiting, he returns back to home. Now the speed has changed to 7.5. The distance remains the same, 2.5. Again 2.5 is the distance, speed is 7.5. So what is the magnitude of average velocity? Average speed of the man over the interval of time, 0 to 30 minutes, 0 to 50 minutes and 0 to 40 minutes. So time taken by the man to reach the market, see, speed equal to distance by time. In order to find time, it will take as time equal to distance by speed. What is the distance from here to here? 2.5 km. What is the speed? 5. Initially the speed was 5. So 2.5 by 5 is half hour, which is 30 minutes. Now when he is returning back, the distance remains the same, but the speed increases to 7.5. It will be 1 by 3 hours, that is 20 minutes. So what is the total time? This 30 minutes plus 20 minutes, which is 50 minutes. Let us find the velocity now. Velocity is displacement by time and average speed is distance by time. In the first case, from here to here, it is 2.5 distance by half hour, right? 5 km per hour. Average speed is distance by time. Again, this is again 2.5 km and again half hour is being taken. So we are talking about the first case. This is again 5 km per hour. So we see velocity and speed are equal here. Total time is 50 minutes. Let us divide this by 60 so that we can get it in hour. But what is the net displacement? He starts and he comes back again. So initial and final position are same. So displacement is 0. But total distance is 2.5 here, 2.5 here. So it becomes 5 km. What is the average velocity? It is displacement by time. Displacement is 0. It becomes 0. What is average speed? This is distance by time. Distance is 5. And what is the time? This is 5 by 6 hours, 50 minutes in all. So this will be 6 km an hour. Now the speed of the man while returning back is 7.5 km. And distance traveled in the first 30 minutes is what? From here to here, it is 2.5 km. So what is the distance traveled by the man in next 10 minutes? 30 minutes is okay, but for next 10 minutes, 7.5, the speed of the man when he is coming back, because 30 minutes he has passed here with certain speed. Now when he comes back, the speed changes to 7.5. So 7.5 into 10 minutes, 10 by 60, that is 1.25 km. Now he has come 1.25 meter here on this side. 2.5 is total distance. So what is the displacement from this point to this point, which is 2.5 minus 1.25, which is 1.25. But what is the distance traveled? 2.5 is this one, distance we are talking about. 1.25 is this one. So in all, total distance traveled will be 3.75. Now let us again find the average velocity and average speed. Average velocity will be this distance, displacement, divided by the time, which is 40 minutes, so 40 by 60. The average speed is, because the distance we are going to take 3.75, again 40 minutes, that is 40 by 60. So this gives you average speed. We have carefully distinguished in the previous discussion between average speed and magnitude of average velocity. No such distinction is necessary when we consider instantaneous speed and magnitude of the velocity. So the instantaneous speed is always equal to the magnitude of instantaneous velocity. Why? The idea is the instantaneous velocity, if the path is like this, if we take an interval, we find the average speed or average velocity. But when we have to find at certain point, some specific point, we have to find out the velocity or speed, we call it as instantaneous velocity. And instantaneous velocity is simply the first derivative of distance with respect to time. So ln is dx by dt. So the time interval, this dt is so small, it's very small, that the particle is assumed that it doesn't change the direction of the motion because it is very small. How can you explain the change in direction of motion in such a small time? So both path length and magnitude of displacement here becomes equal in this time interval. That is why the instantaneous speed is always equal to instantaneous velocity. We have certain graphs. We have to state with reason which of these cannot possibly represent two one-dimensional motion of a particle. When we are talking about one-dimensional motion, we have to understand that at same time the particle cannot be in two positions. See, at this time this particle is at this point, and see this one v1. If you draw a time, so say certain time, it is in two position, right? Here the speed, this is a graph where something is increasing but something is decreasing also. Whether it can decrease, this is total path length. Can total path length decrease? If you go here from here, this total path length, it adds up, so it is not going to decrease anytime. So you can see that these three are outrightly discarded. So let us take one by one, then discuss it again. In this xt graph, this is a graph does not represent one-dimensional 1D motion of the particle. Why? Because this has at the same instant of time two positions. Similar case is with this. It also does not represent one-dimensional because particle can never have two positions or two velocities at the same instant of time. In this case, it does not again represent one-dimensional motion. Why? Because speed and t, this is a scalar quantity, and scalar quantity, how can it be negative? It cannot be negative. And this case, it is path length by time. Path length can never be negative. Path length has to add up. It has to add up. So it will go like this only. It will never come down. In this figure, this shows the xt plot of one-dimensional particle motion. Is it correct to say that the particle moves in a straight line for t less than 0 or on a parabolic path for t greater than 0? If not, suggest a suitable physical context for this graph. The answer is outright no. The xt graph of particle moving in a straight line for time which is less than 0 and on a parabolic path like this for t greater than 0, it cannot be shown like this. Why? Because this particle does not follow a trajectory of path followed by the particle which is t equal to 0, x equal to 0. And a physical situation is which resembles this is an object which is falling freely and from certain height. A police van moving on a highway with a speed of 30 km fires a bullet at a thief car. So police is here, thief is here, it is firing some bullet, speeding away in the same direction. So both are moving in the same direction. Now the bullet speed is 192, coming from 192 km an hour, going, which is this speed, the speed of the thief car. And police van is very, very, very slow. But the muzzle speed of bullet is very fast, 150 meter per second. So with what speed does the bullet hit the thief car? The answer lies in the relative version. The speed of police van 30 km per hour multiplied by 5 by 18 in order to get meter per second. The muzzle speed is Vb, that is, we take it as Vb, that is 150 meter per second. It is already given. Speed of thief car is 192 km an hour multiplied by 5 by 18, you get 53.30. Now since it is this, you can say revolver is inside this van or police van, This policeman is already moving with a velocity of 8.33 and the velocity is 150 of the muzzle. So this velocity will add up. So 150 plus 8.33 will be the actual velocity of the bullet being fired. And now though the both vehicles are moving in the same direction. So velocity with which the bullet hits the thief car will be simply VBT, VB minus VT, 158.33 minus 53.3, which is 105 meter per second. You have to suggest a suitable physical situation for each of these graphs. See, the first graph, this is a XT graph. It shows that body is at rest. Then its velocity increases with time and it attains an instantaneous constant value here. The velocity now then decreases to 0 and it increases with time. Right? Then this velocity increases in the opposite direction and it acquires a constant value now. This situation comes where? A football, when it is kicked, say a football is being kicked, it hits and it comes back. This is this physical scenario which can explain this graph. Next is this one. The sign of velocity, it changes and its magnitude decreases with passage of time. This one, it is decreasing. At some time it will become 0. So what will happen if you just throw a ball like this on the floor? So it will jump sometime. After that it is going to come on the rest. So it decreases, the velocity decreases by certain factor, eventually it becomes 0. The last one is, this is a AT graph. This AT graph shows that initially the body is moving with a certain uniform velocity. Its acceleration increases. Now acceleration increases for a short interval of time. Then it drops again. What is this is indicating? A body starts moving with some constant velocity. This will come when you hit hammer, a nail with a hammer. This is the physical scenario. In this figure, this is a XT plot of particle executing one-dimensional simple harmonic motion. We'll talk about this in the later discussions sometime. But we'll give you a formula. Give the sign of position, velocity, acceleration variable of the particle at t equal to 0.3 seconds. That means somewhere here. And it is very easy to find out. This is negative, this is positive, like this. At 1.2, somewhere here. And minus 1.2 somewhere here. So the first is at t equal to 0.3 second, as you see here, 0.3 second. The three things which are being asked is the position and velocity, both are negative. Position and velocity both are negative. But the acceleration is positive here in this case. Then in the second case, we have, because how to find out the acceleration? Acceleration of simple harmonic motion SHM is given by A equal to minus omega square x, where this omega is angular frequency. So on this basis, we'll find out the acceleration. This position and velocity is quite easy to find out from XT graph. In this second interval, which is the second one, which is this one, t equal to 1.2 second, the position and velocity, they both are positive. But if you put the value in this acceleration value, you get minus, that is negative. In the third one, which is t equal to minus 1.2, the time interval in this x is negative now. And the slope of this XT graph gives what? It is negative at this point. And both x and t are negative. The velocity becomes positive. And if you put the values here, it can be found that acceleration of the particle will be positive. In this figure, it gives XT plot again, the particle in one dimension. Three different equal intervals of time are shown, 1, 2 and 3. In which interval is the average speed greatest and in which it is least. Also give the sign of average velocity for each interval. In XT graph, velocity can be found out using you can take the tangent, or you can take any tangent and slope of that will be giving you, that is dx by dt or delta x by dt, that is going to give you velocity. Now, in the first case, you see, in the interval 3, it is greatest. The greatest speed has been asked. So, in interval 3, it is greatest. In interval 2, it is least. In the interval 1 and 2, we have certain things which are positive. That is, in the third one, we have negative. What is positive, what is negative? Let me tell you. Now the average speed of a particle, this is shown in xt graph. How to obtain this? We have to find the slope of a graph in a particular interval of time. Now from the graph, the slope is maximum and minimum at 3 and 2. See, this is the maximum slope. And then this is the, if you come, this is the minimum slope. It has more slope. These two have more slope than this one. So this is minimum, this is maximum. So average speed of a particle is greatest in the interval 3 and least in interval this one. This is very clear. Now how about the sign? The sign of average velocity is positive in interval 1 and 2. So because this is above, 1 and 2 are positive. In 3 it is negative, right? Because it is on the downside. And the value, which is the slope, is also coming negative. Figure 3.25, this figure shows a speed time graph of a particle in motion along a constant direction. 3 equal intervals of time are shown, 1, 2, 3. In which interval is the average acceleration greatest in magnitude? In which interval is the average speed greatest? We have to choose the positive direction as constant direction of motion. We have to give signs to V and A in the 3 intervals. And what are the acceleration at point A, B, C, D? A, B, C and D. See, first of all, this is speed time. So what is the acceleration? This is given by dx by dt. So average acceleration in this interval 2 is greatest. Average speed in this interval 3, this one, is greatest. Average acceleration is greatest in 2. Average speed is greatest in 3. V is positive in 1, 2, 3 because you are getting a positive slope. And 1 and 3. 1, 2, 3. And in acceleration, 1 and 3, these are negative. And interval 2, right? This 1 and positive in 1 and 3 and negative in 2, this interval. How? You just have to take the, find out these d2x by dx2. That is what we find out. But let us discuss them. First, let me tell you the background. Acceleration is what? It is given by the slope of speed time graph. That is how I told you these signs. It is given by the slope of the speed particle graph with a given interval of time. It is given here. And when the slope of given speed time graph is maximum in interval 2, because this slope we are talking about. In 2, this is maximum. You are getting maximum slope. Average acceleration will be greatest in this interval. How about the height? The height of the curve, this height of the curve from the time axis, it gives you the average speed because it is speed time graph. So it is clear that the highest is this one. So it is greatest in 3. The average speed of a particle is greatest in this interval 3. So first of all, let us talk about interval 1. The slope of the speed graph is positive here. You see this, if I drop a tangent, it is positive. So the acceleration is positive. The speed of the particle is also positive in this interval. When we go to this second interval, this is the slope of the speed time. See, this slope is negative. So acceleration is negative. But the speed is positive because it is a scalar quantity. When you come to this one, the slope of this one is 0. This is slope which is 0. So acceleration is 0 in this interval. But the particle is acquiring some uniform speed. So that is the positive. It is positive in this interval speed. But at A, at B, at C and at D, all these points we have line parallel to time axis. The slope is 0 at these points. So A, B, C, D, at these points acceleration of the particle is 0. So these were question and answered on motion in a straight line. Thank you so much. Take care of yourself.